This video is going to go over lesson 4-4, which is looking at expanding expressions. So if you take a look at the solve and discuss it on the screen, you want to go ahead and read over that. It says the school is planning to add a weight room to the gym. If the total area of the gym and weight room should stay under 5,500 square feet, what is one possible length for the new weight room? Show your work. Are there other lengths that would work? Why or why not? So right now what I want you to do is go ahead and pause, see if you can come up with an answer, and then when you're ready to check, you can go ahead and hit play again. So go ahead and notice what I did on the screen. The first thing I did was find the area of the school gym, which was 4,950. The second thing that I did is I took how much area, which was the 5,500 square feet, and I subtracted that 4,950 from the total area of both rooms, the weight room and the school gym. Then I knew that the weight room was X feet, which is what we were trying to find, and I knew that it was 55 feet wide or tall because of the opposite sides being equal. So what I did from there is once I figured out that the area of the weight room could be 550 feet, I set up an equation. So I thought about how can I find the area of a rectangle. So I did 55 times x equals 550, and then I solved for x. So I found that x can equal 10. The one thing that's really important to remember though is if you read the question carefully, it says that the total area of the gym and weight room should stay under 5,500 feet. So if it has to stay under 5,500 feet, that means that x cannot be equal to 10. X has to be equal to 9 or anything that is less than 10. So x has to be less than 10. So there are other lengths that would work. We just have to make sure that the length, the x feet, is less than 10 for our measurement. So very quickly, I want to review the distributive property. With the distributive property, we are basically taking multiplication and addition, and we are combining them together. Sometimes you'll have multiplication and subtraction, but remember that when we're working with integers, that subtraction sign becomes an addition sign, and then we add the opposite. So in this case, we would add a negative, or we could add a positive. It just depends on the situation. So we are going to take a look at some of our examples today because we want to make sure that we understand the distributive property before we actually jump into this lesson. So if you take a look, some of the problems that you're going to see today may look like this: 5 times a plus 3. And you're going to be asked to write this in expanded form. So right now we are in factored form. And how do I know I'm in factored form? Because I can see that I have a number, one number out in front. Remember that whenever I see a number next to a set of parentheses, I am multiplying. So I'm going to multiply 5 to the a, and that's going to become 5 times a, and I'm going to put that in parentheses. And then I'm going to share the 5 to the 3 and do 5 times 3. And then I have my addition sign. So my expanded form would look like 5 times a plus 5 times 3. If I wanted to, I could then solve it, where this would become 5a plus 15. And that would be our simplified form because we don't know what a is equal to. Let's take a look at another example. So if you take a look at this problem, we have 2 times a plus 3 minus 7b. So notice this time we have 3 terms in our parentheses. We are still going to do the exact same thing where we are going to share the 2 with each item or each term inside the parentheses. Before I start doing that though, I want to go through and make sure that each of my signs are addition. So I'm going to change this subtraction to addition and then change 7b to a negative 7b. Remember, we want to add and then the opposite. So now I can go through and I can do 2 times a and then I'm going to put a plus sign because that's what's here, and then I'm going to do 2 times 3, another plus sign because that's what's here, and then I'm going to do 2 times negative 7b. Remember that when you are combining terms, if you are multiplying, you can put a letter and a number next to each other or together. So 2 times a would simplify to 2a, 2 times 3 would simplify to 6, and 2 times 7b, this is where we would do the 2 times negative 7 first, which would get me to negative 14, and then the b comes along for the ride. So this would be my simplified form because I don't know what a or b is equal to. Let's take a look at 2 more. So I'm going to go ahead and write these, and then you're going to try this somewhere on your note sheet, worksheet. So if you have 4 times negative 3a plus 2, and then you have 6a times 2 minus 3d. Okay, so go ahead and try those and see what you can get, and then we'll go ahead and walk through them together. So you should have changed these into expanded form, and I probably should have specified that. So we're going to go from factored to expanded form. So again, if you're looking at the first example, I noticed that my addition sign is already an addition sign, so you don't need to worry about changing that into an addition sign or changing the sign. So I can go ahead and just share the 4. So I'm going to do 4 times negative 3a, and then I'm going to share the 4 with the 2, so I would have plus 4 times 2. If I want to, again, if the question asks me or I just want some practice, 4 times negative 3, so I would do the whole numbers first, would become negative 12, and a comes along for the ride, plus 4 times 2 is 8. This again would be my simplified form until they tell me what a is equal to. If I take a look at the second example, I'm going to take, well, first I'm going to change the subtraction to addition. So I'm going to change and change. So change to addition, change to a negative 3d instead of a minus positive 3d. And now I can go ahead and share. So I'm going to write out 6a times 2 plus 6a times negative 3d. Notice that in this first set of terms or set of numbers, I have 6a times 2, so I'm going to do 6 times 2 is 12. A comes along for the ride, plus, now notice that I have 2 whole numbers, and then I have 2 different letters. That's okay. I have 6 times negative 3, which is negative 18, and then the A and the D both come along for the ride. Because I have 6A times negative 3D, well, 6 times negative 3 is negative 18, and then after I get that negative 18, it's A times D. So let's go ahead and jump into our lesson. Like I said, I wanted to give a little bit of a precursor on the distributive property because you'll notice that in the first example, we're talking about expanding expressions using the distributive property. So if you take a look at this problem, it talks about how a family farm wants to add a blueberry patch to the end of their apple orchard. So if I take a look at this blueberry patch, I see that right here, I'm missing a length. Okay, so I don't know the length of the blueberry patch. I know that the apple orchard is 2.5 kilometers long and is 1.5 kilometers wide. I know that because opposite sides would be equal. So what I'm trying to do right now is figure out the total area of land. Well, I don't know what x is, so I'm going to keep x as part of my expression. So what I'm going to do is I'm going to think about, how do I find the area of the apple orchard? I multiply 2.5 times 1.5. How do I find the area of the blueberry patch? I multiply 1.5 times x. If I look at these two things, or these two sets of numbers, I know that to find the entire area, I would need to add them together. So my expression would look like 1.5x plus 2.5 times 1.5, which is 3.75. I cannot combine or make this any simpler or shorter because I don't know what x is yet. So what is the total area of land? 1.5x plus 3.75. Go ahead and take a look at this, try it, and try it. So you are taking the 3.6 times t plus 5, this is your factored form, and you are going to write that into expanded form. Okay, so go ahead and do that. So we're going to do 3.6 times t plus 3.6 times 5, because again, we're looking for factor or expanded form. We are not solving. We are writing, we're going from factored to expanded. Example 2 is talking about expanding expressions with a variable. So if you take a look at this example, we have x times -2 minus 0.5 y. The first thing I'm going to do is I'm going to keep -2, change the subtraction sign to addition, and change 0.5y to -0.5y. Now I can go through and I can share the x. Just because we have a letter or a variable outside of the parentheses in our factored form doesn't mean we can't share it the same way. So we're going to end up with x times -2 plus x times -0.5y. This would be our expanded form because we're sharing the x, which would then show up in both of our sets of parentheses. If we wanted to simplify this down so that it would be in our standard form, which is kind of like our final answer, all we would need to do is work through the multiplication. So x times -2 becomes -2x. Our plus sign comes down, and then -0.5y times x would become -0.5xy. Until we know what x and y are, we can't simplify that anymore. So now we're going to look at this try it, which is talking about expanding the expression. So again, this is an expression that's written in factored form. Try and get used to this terminology. You want to write this in expanded form. So go ahead and try that example. So if you tried the example, you should have gotten t times -1.2w plus t times 3. Again, if you want to write that in standard form, this t times -1.2w would become -1.2. You always keep the whole number the same. tw plus 3t. Last example is expanding more complex expressions. So this is similar to one of the distributive properties that we looked at before, where you'll notice we have 3 different terms. So I'm going to go ahead and expand this out or rewrite it. So I have 2 minus 3x plus 3. Again, I'm going to go through and change any of my subtraction to addition, and then change the sign of the next term. And now I'm going to share that -1/3 with each piece. So I have -1/3 times 2 plus -1/3 times -3x plus -1/3 times 3. So now I'm going to go through and simplify each piece. So I'm going to make each of my whole number terms a fraction. So if I take a look at the first piece, -1 times 2 becomes -2. 3 times 1 is 3, so this becomes -2/3, plus -1 times -3 is +3. X comes along for the ride, over 3. Again, multiplying straight across, plus -1 times 3 is -3. 3 times 1 is 3. So now the last step I'm going to go through is simplify any of my fractions if I can. -2/3 is equal to -2/3. 3x divided by 3, these 3's cancel, so I'm left with an x, plus -3 divided by 3 would become -1. Final step, combine any like terms. So I'm going to go ahead and combine -2/3 and -1. And I'm going to write my final answer up here because I kind of ran out of space. So I'd have -1 2/3 plus x. I know that's a lot. So let's look at another example. You'll see that this one also says to simplify the expression. So we're looking at, again, a more complex distributive property question, but it's very similar. It's a little nicer because we don't have as many fractions. We have whole numbers. So again, we want to go through and change. So I see this is a plus, this is not. So we want to change this to a plus and then a minus. And then I'm going to share. So I have -2/5 times 10 over 1 plus, notice I'm drawing the arrow as I go, -2/5 times 15m over 1 plus, one more, -2/5 times -20 and over 1. So again, we're going to go through and we're going to simplify. So -2 times 10 is -20. 5 times 1 is 5, so we get -20 over 5. -20 divided by 5 becomes -4. Next set, -2 times 15m would become -30m over, then 5 times 1 is 5. -30m, or -30 divided by 5, is going to be -6, and then the m comes along for the ride. Last set of terms, or last set of numbers, we have -2 times -20, which would be 40, and then the n comes along for the ride. 5 times 1 is 5. 40 divided by 5 is 8, and then the n stays beside the 8, so that when we figure out whatever m or n is equal to, we can substitute and solve. So let's look at one more example just to make sure that we're all kind of on the same page. So if we take a look, let's say we have 2x times -4 plus 1/2 minus 3y. So remember, again, we want to go through and change any of our subtractions. So this is addition, this is a subtraction, so we want to change that to addition. So add the opposite. So we are going to now be in good shape to share the 2x. So we're going to go ahead and take 2x and multiply it by each term in the parentheses. So we're going to have 2x times -4 plus 2x times 1/2 plus 2x times -3y. Again, we're going to combine what we can. So 2x times -4, 2 times -4 is -8, x comes along for the ride, plus 2x times a half. 2 times 1/2 is 1. X comes along for the ride. Finally, 2x times negative 3y. 2 times negative 3 is negative 6. X comes along for the ride. Y comes along for the ride. So this would be my final answer. Now, one thing we can do is we can take our negative 8x plus x plus negative 6xy. Notice I got rid of this 1 because 1 times anything is itself. And I can actually combine one more thing, which would be the negative 8x plus the 1x. So if I have negative 8x and I add a positive x to it, that's going to result in negative 7x plus negative 6xy. So this would be my final answer. So make sure you have all of these examples written down somewhere on your paper. You had more than enough space, so hopefully you were able to get the extra examples that we did written down as well, and this will help you then practice a little bit more as we move forward with this lesson.